Well, we've got Hurricane Florence making its approach into the North Carolina coast this evening. So we'll be looking at that shortly, and that's a look from the bird's eye view there. Looks pretty fair in our area, but we've got the storms rolling back in because precipitable water, in spite of how it looks in this image, it's actually up over 2 inches. Maybe that's some of the bluish color that we see there, some of the moisture in the atmosphere. So let's check out Florence and get this centered. There we go. So yeah, current location of the storm, we can grab that right off of the radar imagery, and that's looking to be about 33.95 north and 76.4 degrees east or west. And that's moving very slowly to the west-northwest. In fact, it's slowed down quite a bit, and over the 1 or 2 hours of this animation, it looks like it's only moved about 10 miles or so. Inland, we've got a couple of tornado warnings for that area, pretty much north of Morehead City, kind of in this Bay Area, Pamlico Sound, and there goes that warning. And let's see what that's for. Now, typically when we have hurricanes making landfall, the spiral bands on the left side, on the forward part of the storm, those can be kind of a favorite area for development. And let me get my cursor back. Hang on. A little Minecraft. All right, so yeah, we're looking at that area right there that's favored for development. And now you see these spiral bands right here. Those are kind of an area that we look for development in, and especially when we have these splotchy towers right here with the higher intensities, those are really what we need to be watching. Most of what we see in here, that's the inner spiral bands. However, it's got a more stratified appearance. That's not to say we can't get brief tornadoes in that, but typically we see that in the stronger storms such as Andrew. But in the weaker storms like this, we kind of look for mostly in the outer and in the middle parts of the spiral bands there. Now you saw that tornado warning around the New Bern area, and let's take a look at that and see what caused that. So let me flip over and find where that pops up. Okay, so there it is. Pops up right there about, looks like about 20 minutes ago. So we'll grab the image right before that happened. So obviously, you can see that cone shape, and the storms are moving that way. So it's something in here that triggered that warning. So we'll zoom in a little bit on that area. Do we see anything obvious in here? Well, not really. And that kind of underscores the difficulty that they've had forecasting hurricane-produced tornadoes with just the old school radars, just using reflectivity. But when we go down to velocity, we see a much different picture. Now you see something that is a little bit irregular. So embedded in this large area of inbound winds, we've got that shear couplet right here. So that really stands out. And that's basically showing us where we have, let me zoom in real tight on that. This is showing us where we have very strong inbound right where that purple is, and then we have very weak inbound right there. And that's embedded in this larger area of like medium inbounds. So that little weak inbound right there, and I'll put W for that, and this strong one, that forms an area of shear between here and there. So across that zone right there, that forms a couplet. So we actually have, from a storm relative perspective, we've got inbounds and outbounds like that. And we can subtract out the storm motion a bit, and I went ahead and set that up. And this looks a little bit more familiar like we see with severe weather. So if this was a severe weather event, the radar's obviously down that way. So here we have outbounds, and here we have inbounds. Okay, so that makes a lot more sense. And we can take a look at the shear there. Looking at about 49 in and about 17 out. That's about 60 knots of shear across 1 mile. So certainly, yeah, that definitely stands out right there. Now another product we can use is spectrum width. Wow, now we can really see something there. Now, I'm not too sure what would be causing these heightened spectrum width values. That is basically indicating a higher diversity of velocities within that volume. So probably what could be happening in there is maybe different sizes of precipitation. Maybe there's a little bit of sorting going on in there. And different sized particles have different terminal velocities, and they behave differently within that strong airflow. So that can give us a pretty high range of velocities within these volumes here. Now if we go back to that velocity product there, there's a little bit of shear in this region right there. Maybe if we use spectrum width paired with that, that might give us possibly some areas to watch. So definitely some of these products are much better to use than just your standard reflectivity, and that just shows just a bunch of rain. So that's how we go about finding those tornadoes, zooming in on those spiral bands. And what we like to watch also is these cells that are coming inland right down here. They often form kind of a conveyor belt of supercells coming in, and we especially saw that last year with Harvey when it came into Texas. They were kind of all stacked up southwest of Houston, and we just had a series of tornado warnings for Liberty County in that area right there. So anyway, that's the tornadoes, or the tornado warnings, I should say. I'm not too sure if we've had any confirmation on that. And the higher values, the higher winds are going to be coming kind of in this area right there. And we've got a couple products set up where we'll check that out. So we'll look at that in just a bit. Okay, so yeah, there's Florence. Finally has approached the U.S. coast. It is a low-end Category 2 storm. It's a lot weaker than it was when it was out in this region right there. It was a Cat 4 storm earlier. Now it's down to 85 knots sustained, so just barely up to 100 knots there. The pressure, though, is still down around 955 millibars. That's not very low. Your major hurricanes are going to be in the 890 to 920 range. So yeah, this is pretty much what we would see with a Cat 2, Cat 3 storm. And let's see, let's take a look at some of the other systems. There's that disturbance there off the Texas coast, producing a lot of showers there in the Gulf region. Also, we have Isaac now tracking into the Caribbean, 35 knots on that. That's kind of a weak storm right there. However, the European model is taking that into the Gulf of Mexico. Not seeing that so much with the GFS, but that could be a factor in the Gulf, maybe about 6 or 7 days from now, up in this region right there. So we got a ways to go as far as that goes. And then we have Joyce and Helene way out there in the Atlantic. Joyce is tracking very slowly south, and then it's going to pull north, and then Helene, of course, is moving very quickly to the north and towards the British Isles. Should be up there early next week. Okay, let's check out the winds on the North Carolina coast. This is a system called MADIS, M-A-D-I-S, which is run by NOAA. And this pulls together a lot of different sources from a lot of state mesonets and also some private mesonets, and puts all the data together, and we can go ahead and refresh this and get the latest wind values. And this has a lot of buoy data just off the coast there. So we can see right here, this is near the center of the circulation. This buoy is picking up 112 knot gusts. So we're looking at 53 with gusts 112. And the other readings in that area, 96, This one is 134, but the wind speed is only 44, so that might be a little bit suspect there. That's just off the coast of Wilmington. Yeah, seriously doubt that 134 is valid. And then on the south side of the circulation, probably northwest winds there, gusting up to 58. And that's about all we have out in that area. So one other way we can get velocity is to look at base velocity on the radar. And this only gives us kind of an approximation because as you move away from the radar, you get higher and higher up in the atmosphere. And this is up at about 5,000 feet, but at least it will give us some numbers. We can see it looks like 90 to 100 knots in this area and about 105 to 110 up at that level. And that probably corresponds to about 75 to 85 knots down at the surface. So what we see here on this image, a lot of inbounds towards the radar. And let's see here. Let me just keep things moving. We do have a couple of watches in effect, or looks like one right there. So that's a tornado watch for the North Carolina coast. And this is the SPC Mesonet right there showing the circulation off of Morehead City tracking towards Wilmington. And we can bring up a few products just to see what the SPC Mesoscale Analysis looks like. Moisture convergence, it's pretty much stacked on the circulation right there. So the winds are converging in this area, bringing moisture into the center of the storm. The product is not really all that useful, but the patterns kind of show you a little bit about what's going on. Divergence and vorticity, showing very high vorticity right there in the center of the storm. And let's see, pressure change, we can do that. There's the center of the storm right there, and we can see pressure falls in this area right here. So that could be a sign that the storm is tracking right there into the center of those pressure falls. Typically low pressure moves towards centers of height fall regions. That's a technique that we use occasionally in severe storm forecasting. Okay, we'll go to the upper air analysis. Got a trough off the west coast right there, a very large trough. Got the polar vortex in full effect up there in northern Canada. And a pretty well-developed polar jet coming around the base of that from Oregon and Idaho on up to Ontario. And you can see the winds picking up there in Utah. We're seeing conditions kind of becoming a little bit active in that area weather-wise, and that's helping to fan a couple fires in the Provo area today. So we'll see that on the satellite loop. Going back to Florence, we've talked about the steering current over the past couple days. There's the Florence right there. This is the 500, 850 millibar winds. So this is about 5,000 up to about 20,000 feet. And if you just kind of remove the storm from the map mentally and kind of look around the edges, you can see that the velocity, this very dark blue, is very low. So the storm is moving up into this region of very weak steering flow. And that's helping to slow that down right there. Okay. We'll just take a look at the thickness and get a quick overview of the frontal and thermal setup. There's our storm coming onto the coast, but things are changing up in central Canada and the western U.S. And there's a strong cold front coming into Nevada, and kind of a series of fronts all the way up to Wyoming and South Dakota and up into Minnesota. And it looks like that connects up to kind of a major system up there in Ontario. So if we draw the fronts on, we get something like that right there. And yeah, lots of cold air up in British Columbia, off the Pacific coast, and on especially up into the Northwest Territories there. So, yeah, some of this cold air may be working its way towards the southeast and affecting the Great Lakes and Midwest over the next several days. Okay, up next, I've got to, let me see, I'm trying to figure out when to pull in the rest of the Florence products. I guess we can go ahead and do that now. So let's, let me just check in on chat, make sure the stream is doing okay. Okay, so we got JT here. Missed the stream. North Carolina coast around Morehead City. Taking a beating there. Got Sue M here. Erica Baker up there in southeast Kansas, 83/70. Andrew Hotchkiss wondering why Florence weakened. Well, we'll look at that shortly. I've got the OHC products coming up shortly. And Fun with Tech is here. Ryan Toomey's. RDC Tarantula saying it was hot in Minneapolis. David Lumbert, Little Rock, 87/70. We got Burl H here and Havarius, hello. Willie Greenway in Georgia. Average Joe Desert Gardener, hello. Ron Chalfont, Southern California, clear and fall-like in that area. Got Carl Berghoff here and Zelkuda. I appreciate the comments there. Paul Tukowski, glad that his daughter is no longer in New Bern, North Carolina. Ryan Toomey is reporting waterspout. Carl Berghoff talking about the correlation coefficient product. Yeah, good catch there. Shirley Keast, 73 up in the UP of Michigan. Cthulhu seen a little buffering. Let me check the stream health. Oh, where did my yeah, there it is. Okay, yeah, we dropped 653 frames. That's not too bad. It's only about 20 or 30 seconds there. Ligma, hello, and Alpha Lax, Carl Berghoff, and Dodge Ver, Drizzly, and Aggieland. All right, so yeah, the products for Florence, let's put that up there. This is the infrared imagery going back 24 hours. And we'll watch that as it tracks towards North Carolina there. And pay attention to the color shading. You can see it kind of intensifies briefly overnight. Then as we get into the morning hours, we start losing those reds and deep greens. You can see it falling apart there. Then we get one last shot there during the afternoon, some red showing up. And now we'll take a look at the Dvorak curve. And this is what we use to track intensity. So this goes back 24 hours. Don't see a well-defined eye in there. That's one thing that would make me suspect kind of a weaker storm. Don't see too many of those extensive blacks. You can see it does wrap around briefly, then we kind of lose that black there. Don't get that good concentric pattern that we had in Irma. And then towards the very end, you can see we start pulling in those very bright whites with that stronger intensity. And this is a composite of different platforms looking at the wind field right around Irma, or not Irma, but Florence over the past 24 hours. And you can see that 65 contour shrink down on that very last frame. So we are getting a little bit of weakening there. And then that brings us to the OHC product, and this goes back 2 days. So we'll animate this, and you can see that the system moves over that little lobe of higher OHC, and that gave us that increase to Cat 4. You can see it passing over that yellow. Then it gets into that minima area, so that corresponds to that decrease, and then we get that brief passage over the Gulf Stream, and that gave us a little bit of Cat 3 intensity. It's getting into that shallower, slightly warmer water. That probably helped a little bit with that little burst of energy this afternoon. But I would expect to see it slowly start to trail off a little bit. The pressures are probably going to stay down there, but the other factor is a lot of friction. The circulation is now coming up onto the coast, and that's going to help that fill a little bit more efficiently. So that's going to be probably what we're going to be seeing tonight. Okay, let's see. Let's go ahead and go into the forecast, and we'll also be zooming down on Florence to see what's going on with that. Okay, there's the upper air pattern. So you can see Florence wandering inland, and it's kind of not sure where to go there. Lots of troughing up in the northwest U.S. and up in Canada associated with that cooler air in that region. And then let's see what comes up next. The circulation moves across the Appalachians up in Ohio, and looks like Florence will be pretty much gone around midweek. But we'll leave kind of a trail of rain all the way from South Carolina to around the Blue Ridge Mountains and on up to Ohio and probably Pennsylvania there. The next change during the week, probably the arrival of this trough out west. Lots of ridging holding on across the south central U.S. and into Texas. Then we get into a little bit of southwesterly flow, and that may increase some of the chances of rain, especially on the high plains. Maybe get a little bit of an increase in convective weather in that part of the country. Very deep trough moving into the Colorado and high plains region for the 22nd. And then this will probably get us in kind of an active Pacific front pattern. Maybe a couple fronts moving west to east around the 23rd or 24th, and we will have to watch for Isaac coming up from the southeast there. And then zooming in on things, let's look at Florence. We'll start with the GFS. It's going to be pretty much steady in terms of pressure as it comes into the Wilmington area, and there you can see it moving across the southern counties of North Carolina. And then it looks like it's going to go ahead and take that track into South Carolina, but this interaction with the terrain will be shredding the circulation very gradually during the day tomorrow. It looks like the winds will peak along the coast tonight, and then we'll see it drop off through the day tomorrow. And there's not going to be a whole lot left in the wind circulation tomorrow night, but we'll be putting down a lot of rain throughout this area, probably up later into the Asheville area. And let's see what the European model has for that region. Okay, let's see, get this going here. This is the 12Z European model. Pretty much tracks directly towards the Wilmington area. And then similar to the GFS, it takes kind of a southwestward jog, maybe a little further south than the GFS. In fact, quite a bit. In fact, the European is bringing it almost all the way to Charleston there. So if I was at the forecast desk, I'd probably split the difference on that one. And most of the heavy rain will be, of course, on the north side. Peak winds, looking at all this model data, it looks like in the Charlotte area, gusts will probably reach 45 miles an hour, most likely tomorrow. And for Raleigh, probably 35 to 40, but that will increase quite a bit as you get down to the coast. And the European model does have a wind product. Let's go ahead and run that. These are the peak gusts estimated. This is just kind of like 1.5 times the wind speed. And you can see a lot of the higher gusts are confined to the southern counties of North Carolina, and not a whole lot up in the Raleigh-Durham area and Charlotte. So, yeah, a lot of the heavier winds down on the coast. And keep in mind this prediction is probably a little bit too far south. So probably along the North Carolina and South Carolina counties is where much of this is going to be focused. And then, let's see, the final thing is the possibility of Isaac coming into the Gulf. GFS is not picking up on that, but the European is kind of hinting at that. And if you keep an eye on the south part of the map, getting up to the 20th and 21st, yeah, there it is. Something showing up down there, and it looks pretty weak, probably a tropical depression. But whatever that is tracking up towards Louisiana and Texas, so we'll have to be keeping an eye on that there. Okay. I'm kind of short on time, so I'm going to have to end it here, but I will be back tomorrow. So I appreciate you all watching the webcast, and stay safe, and we will see you tomorrow. All right, take care, guys. Thanks for watching. Bye-bye.